Good morning. My name's James Danger. I'm an embryologist with more than 50 years' experience in IVF, and I'm doing a short takes for Photo IVF Daily's YouTube channel on IVF. The aim of the channel is to create a bridge between the published information that scientific and medical staff use for their development of activities and the information clients need in which to ask their doctor questions during their treatment. It's the awareness of information that makes all the support important. In this particular talk, I'm accessing a free site run by the American Society for Reproductive Medicine. It's called Tech Talk, and this one is on cryotank failure. And just before I start, the business of cryostorage is now a central part of all IVF treatment. Embryos are frozen for later thawing and transfer if they're supernumerary to needed. They may be frozen if all the embryos need to be tested for genetic testing or if there's a risk of hyperstimulation. Sperm are stored. Oocytes are frozen for potential fertility treatment in future years for fertility preservation. But the process all involves something that's similar, whereby all those samples go into liquid nitrogen tanks where they can be stored for a considerable period of time, tens and tens of years. We don't know how long. But all tanks are vulnerable, and they are like thermos flasks that need to be carefully managed and filled. And whilst clinics have an obligation to ensure that the safety of these cryotanks are correct, and everything will be done to ensure that the samples are kept safe, patients coming through IVF who have their gametes or embryos frozen need to be aware that the technology is still vulnerable to catastrophic sudden change, and that clinics have a responsibility to make sure the best practices occurred, and patients have an obligation to ensure they ask their clinic about their safety procedures, but to also accept the reality that there is a risk for storing, and if there is a catastrophic failure and the samples have been destroyed, then as long as best practices have been followed, I think couples should need to accept it, that the risk has been minimised. So this talk is on the ASRM website. It's called the ASRM Tech Committee, and the topic written by Kristen Allen and Stephen Terry and Hans Werdestein is the silent unnecessary risk we take, how to prevent sample damage in the middle of a cryotank failure. So basically, you can read it yourself. I'll give you the link for it. But basically, cryopreservation is now the lifeline for fertility treatment and ensuring reproductive samples remain viable for the future. But as they point out, nothing is forever, and every piece of equipment will one day fail. So what happens when the unthinkable occurs, a cryotank failure? Can we prevent damage before it's too late? The short answer is most likely yes, but the long answer is we cannot guarantee it, and couples need to accept the reality that there is a risk those samples may be lost catastrophically, and all that's been done has been done. So the authors point out that why are the cryotanks at risks? Clinics often store multiple cryotanks, so instead of having one large tank, which can be huge, they often store them in small tanks. One to minimise the risk, but also to make use of small spaces. But it all does require careful handling because liquid nitrogen is dangerous. And if it's in a confined space, can be explosive, and it can be a risk for oxygen deprivation if there is not sufficient ventilation. They point out that you can have a false sense of security if you think you filled it, but you should always ensure that you are measuring the amount of liquid nitrogen in the tank and the amount of liquid nitrogen lost between fills, because that gives you an idea whether there is a sudden loss in capability. So the tanks are filled normally with every nitrogen, usually in a designated period, but it's filled manually, nearly always manually. And like cold water in a thermos flask, As long as the flask is left enclosed and not managed, the nitrogen will very slowly evaporate over a long period of time. But if the rate of liquid nitrogen loss is more than a certain amount per unit time, it could be because of heavy use, but it may also indicate that the tank is starting to have some technological failure. When failure does happen, it's usually sudden and catastrophic, and unfortunately not all alarms are immediately recognised or addressed in clinics, nor are people able to get to a tank and move the samples before the failure has occurred. In recent analysis, missed alarm alerts were observed in 2 clinics. The findings delayed intervention increased the risk of sample loss, and current monitoring methods may not be enough to capture failures in time. So why is monitoring tanks so difficult? As we said before, accurately tracking nitrogen levels is more challenging than it seems, and the greater the redundancy for accuracy, the safer, such as through weight consumption, and 2 levels of temperature tracks. What are the limitations? Often they're limited space, they're often difficult to get to. Putting sensors inside tanks, which are ultra low temperature, and every time a sample is retrieved, the temperature changes in the tanks, putting a lot of stress on the monitoring devices. As they point out, can we detect cryotank failures faster? Simple, but effective solutions integrate temperature, consumptions, and weight loss sensors, but in real time, using sensors as a safety trigger. So how much time would you have to respond? To understand real-life failures, controlled tests were conducted by manufacturers and by simulating cryotanks. The results are eye-opening. You can read that if you like. Timing is critical. If only using a 300mm sensor, it takes 1 hour and 16 minutes for the temperature to rise from 198 to 180. Why does this matter? Once temperatures become higher than minus 180, vitrified oocytes may no longer be viable, making intervention essential. What can be done? Real-time monitoring is a must. Manual checks and data loggers can delay responses. Clinics should always invest in 24/7 live monitoring system that provide alerts. They can be during office hours and out of office alerts, and they're now quite sophisticated systems for cryo management. There should be a standard operating procedure in place that once the alerts have been occurred, should be acknowledged by a responsible person, minimising the risk that failure goes unnoticed. And they point out that prevention is the key. While cryotank failures are rare, when they do happen, tank damage is irreversible, and sample damage can be prevented if managed correctly. With the right sensors, real-time monitoring, and optimized alarm settings, clinics can protect their most precious assets. These are all the cryopreserved samples. Investing in proactive safeguards isn't just about best practice, it's about ensuring the success of every IVF treatment cycle. So you need to possibly ask your doctor when you're having your IVF treatment, are your monitoring systems up to date? And what does the clinic have a response plan in case of failure? If you are unsure of that, maybe you need to go to another clinic. But if the clinic can assure you that these systems are in place and best practices have been occurred, and if there is a catastrophic failure, the likelihood of sample loss has been minimised. But patients do need to be aware that it always is possible, and that should be part of your long-term strategic planning. Hope this information has been valuable. Thank you.